GM records total 1926 Chevrolet production at 486,366 vehicles. One car produced by the hundreds of thousands in a single year. 10 years earlier, Chevrolet was still a young challenger trying to break into the low-price market with its $490 Series 490. Ford dominated that market. Chevrolet now had to prove it could build an affordable car in serious volume. This is the story of how a scattered network of factories, a former Ford production chief, and one obsessive idea turned a $490 gamble into an assembly line empire. Stick around, because the real breakthrough wasn't the car. It was the system built to make thousands of them to the same standards. Chevrolet Motor Company was founded in 1911. Its early cars weren't cheap. They weren't aimed at the mass market Ford already controlled. That was a problem. Chevrolet needed something simpler, something affordable, something that could be built in serious numbers. In June 1915, the company introduced the Series 490. The name told buyers everything. $490. That was the price, and that was the pitch. Just under the prevailing price of Ford's own Model T. Chevrolet wasn't just launching another car. It was challenging Ford on Ford's own ground. In the low-price market, Ford dominated. Underneath the body, the Series 490 was not complicated. A 171 cubic inch overhead valve four-cylinder engine, about 24 horsepower, a 3-speed transmission, a 102-inch wheelbase, nothing exotic. Buyers could choose a touring car, a roadster, a coupe, or a sedan, depending on the year. But the mechanical formula underneath barely changed. That simplicity was the entire strategy. It was a relatively straightforward machine with components that could be produced, transported, assembled, and serviced without the complexity of a modern automobile. The Series 490 wasn't just a model, it was a production problem, and Chevrolet still had to solve it. Here's what most people get wrong about a Chevrolet assembly plant. It wasn't a building where every part came from raw material. Engines, axles, transmissions, some produced in Chevrolet's own manufacturing plants, other components purchased from outside suppliers. Then they were shipped to assembly plants where the pieces were brought together with a chassis and body. By the early 1920s, Chevrolet had settled into a genuinely decentralized model. Flint built motors and axles. Toledo built transmissions. Neither city assembled a finished car on its own. Each one fed a wider system built to bring components together somewhere else entirely. By the 490 era, Chevrolet was running assembly operations in Oakland, North Tarrytown, Flint, Norwood, St. Louis, and Oshawa, parts moving by rail. Different facilities specialized in different operations, while assembly plants brought many of those components together. Chevrolet wasn't building a car in one room. It was coordinating a continent. Imagine the challenge. Components produced in different places, bodies coming from specialized suppliers, and chassis waiting for everything to converge at the assembly plant. Take the Fort Worth plant. 250 by 520 feet, roughly $350,000 to build. A serious industrial facility, not a workshop. A railroad spur reached the plant, making it easier to bring incoming materials directly into the factory. Large windows lit the floor with natural light, row after row of them along the walls. The plant was designed to build 100 cars a day. It didn't, not at first. Supply problems held early output to about 25 cars a day. The first 125 automobiles shipped the week of April 22nd, 1917. 125 cars. That was the beginning of a plant designed for 100 a day. The ambition was there before the capacity caught up to it. Picture the car before it looks like a car. The process begins with the chassis, the foundation everything else depends on. Mechanical components such as axles, suspensions, steering, engine, and transmission then had to be brought together into one working system, with cooling equipment keeping the four-cylinder engine inside its limits. Then came wheels, tires, electrical equipment, and controls as the chassis moved toward becoming a usable automobile. Body and interior work followed as the mechanical assembly came together. No two plants ran that sequence identically. The broad process held, the exact station order didn't. Fort Worth wasn't the whole story. In 1916, Chevrolet opened its Oakland plant. Series 490 production began there on September 23rd. By 1919, Oakland was building roughly 110 cars a day. Meanwhile, in Oshawa, Canada, the first Canadian Chevrolets were assembled there in December 1915. 7,796 cars followed in 1916 alone. Other assembly facilities followed, extending Chevrolet's manufacturing network across North America. A Chevrolet wasn't tied to one factory anymore. It was tied to a system. In 1918, everything got bigger. Chevrolet became part of General Motors on May 2nd that year. More plants, more resources, a production network with real weight behind it now. But joining GM wasn't the fix. The fix hadn't arrived yet. It would come from one man who already knew what high-volume production looked like, because he'd built it somewhere else first. In 1922, William S. Knudsen joined General Motors. He'd spent years inside Ford's own production organization, learning the one system nobody at Chevrolet had matched yet. Chevrolet needed two things: more cars, fewer wasted movements getting there. Knudsen attacked it from the factory floor. Old machines out, new standardized heavy machines in. Fixtures reinforced, inspection made systematic. He wasn't simply transplanting Ford's system. Chevrolet developed its own approach, emphasizing flexibility and sequence line. Machines and workers arranged so the work flowed one direction without doubling back. Knudsen's own words for the goal: get every nose pointed in the same direction. The sequence lines also helped make conveyor-based movement more practical, established in Knudsen's own phrase, to pave the way for the conveyors that would follow. The factory was increasingly organized around keeping the work moving in one direction, one operation at a time. By 1922, the 490s run was over. Chevrolet replaced it with a Superior, starting with the 1923 Series B. Not a different philosophy, still simple, still 4 cylinders. The Superior ran a 171 cubic inch valve-in head engine using a water cooling system with a centrifugal pump, a 3-speed transmission, a semi-floating rear axle. The car had evolved. The factory behind it was evolving faster. By the Superior era, Chevrolet wasn't one enormous workshop anymore. It was a coordinated chain of specialists. Fisher Body moved in close. In 1923, Fisher plants went up alongside Chevrolet facilities in Flint, Cincinnati, Buffalo, and Janesville. Knudsen had pushed GM to attach a Fisher Body plant to each assembly plant, so body production could be coordinated precisely with daily assembly output. Locating those body plants alongside Chevrolet assembly plants reduced the need to ship completed bodies long distances. Chassis, body, components, assembly, all of it moving toward the same finished car. By 1926, the Chevrolet Superior Series V carried a 171 cubic inch 4-cylinder engine, 26 horsepower, a 3-speed floor-mounted transmission, semi-floating rear axle, external contracting rear brake. Base price, $510. Total Chevrolet production reached 486,366 vehicles that year. 486,366. A decade earlier, Chevrolet had a $490 car and a much less developed production system. What had changed in between wasn't one factory getting bigger. It was a dozen separate operations: engine plants, body plants, assembly plants, each with its own city and its own specialty, learning to move at the same pace toward the same finished car without losing a day. What Chevrolet's assembly network teaches you. Lesson 1. The product isn't the whole company. The network around it is. The Series 490 wasn't complicated engineering. What made it work was a coordinated network of specialized plants and components moving toward assembly. The car was simple. The system that built it wasn't. Lesson 2. Capacity and ambition rarely arrive together. Fort Worth was designed for 100 cars a day and opened at 25. That gap showed just how difficult it was to turn a planned production rate into real output. Lesson 3. Borrowing an idea isn't the same as copying it. Knudsen had watched Ford's production system up close for years. He helped Chevrolet develop a more flexible system, built around sequence lines and increasingly organized material movement, rather than an imitation of the system he'd left behind. The lesson traveled. The execution didn't. Lesson 4. Scale is a decade-long decision, not a single breakthrough. The jump from a $490 car to 486,366 Chevrolets a year wasn't explained by any single plant, executive, or model. It was Oakland and Oshawa, GM's resources, Knudsen's production reforms, Fisher Body, and a growing network of specialized facilities, each development building on the others. A Chevrolet from 1915 wasn't simply built by hand, one complete car at a time. It was already standardized parts, specialized factories, and a network moving in one direction. 10 years later, that same idea, pushed harder, was turning out 500,000 cars a year. And the factory, not the car, was the real machine.